All right, we're on to chapter 3, and in chapter 3, we're going to be looking at sensation and perception. So, in the previous chapter, we were looking at the brain and all the physiology and how your brain processes the information. And so, now in this chapter, we're going to get a little bit more specific about what your brain does with the input that comes in from your various senses. So, we'll be looking at your sensational senses, we'll be looking at the process of vision, hearing, as well as your other senses. So let's start with a couple of definitions. The first definition is sensation, and sensation is the detection by your sense organs of physical energy that is being emitted or reflected by physical objects. So, the way that we learn about our world is through our senses, as we talked about in the previous chapter, through our eyes, our ears, our nose, our mouth, and our skin. And so sensation is that process of taking in that raw data, taking in that physical energy, and then getting that into your brain so that your brain can then process it. So sensation produces this immediate awareness of all the sounds, the colors, the form, as well as other building blocks of our consciousness. So now, once that information comes in through your senses, perception is the process of your brain making sense of it. So it's the way that your brain organizes the information and interprets all of that sensory information that's coming in from the environment. So again, sensation is kind of your window to the world, and perception is making sense of what comes into it. So, if you'll remember in the previous chapter, there were three types of neurons: your sensory neurons, your motor neurons, and your interneurons. So, your sensory neurons take in all of that sensory information. All of your senses have receptor cells. Your eyes, your ears, your nose, your mouth, your skin are covered in sensory receptor cells to take the information from the environment up into your brain so that your brain can then process it through the process of perception. So we respond to all different kinds of energy, but the overall process of sensation is the same. The sensory receptor scouts out and gets the sensation. The sensory nerves in your peripheral nervous system transmit that information up to your brain, and then your brain makes sense of it. So, how do your sensory receptors take this raw data that's coming from your environment and then convert it into some kind of neural impulse so that your sensory neurons can then send that information up to your brain so your brain can process it? Well, that process is called transduction. So, transduction is taking that information from your sensory receptor cells on your eyes, your ears, your nose, your mouth, and your skin, and then converting it into a sensory neural impulse so that your sensory neurons can then send that information up to your brain. So, how do we measure that sensory information that's coming in? One measurement that we can use is called absolute threshold. And the absolute threshold is the minimum amount that you can detect 50% of the time. The absolute threshold is the minimum amount that you can detect 50% of the time. So that's how much your senses can detect that information is actually coming in 50% of the time. So here are some examples of absolute thresholds that scientists have discovered. So one example is for vision, being able to see a candle flicker 30 miles away on a clear, dark night. Now, obviously, that's not probably going to happen in Houston, Texas, but imagine you were out in the middle of the desert and it was pitch black to where you could hardly see your hand in front of your face. But 30 miles away on a clear, dark night, you can detect a candle flicker 50% of the time, which means the other 50% of the time, you can't detect it. All right, so for hearing, it would be hearing the tick of a watch from 20 feet when it's totally quiet. For smell, it's a single drop of perfume in a 3-room apartment. You can smell it 50% of the time, which means that 50% of the time you can't. For taste, and this is a fun one to check out on a friend or family member, the teaspoon of sugar dissolved in 2 gallons of water. A teaspoon of sugar dissolved in 2 gallons of water, you can detect it 50% of the time. And then my absolute favorite, I'm not sure how they figured this one out. I guess they lined up a bunch of undergraduates and they wanted to see if you dropped the wing of a bee on your cheek from 1 centimeter away, you could detect it 50% of the time. I don't know how they came up with that, but that is an example of absolute threshold. You can detect the sensory information 50% of the time. Okay, so we talked through absolute threshold, which is the minimum amount of stimulation that can be detected 50% of the time. What is the smallest amount that you can detect 50% of the time? Now, the difference threshold is how much change in order for you to be able to tell a difference, either making it greater or making it smaller. So, how much do you have to change the stimulus in order to detect a difference 50% of the time? So, imagine that your mom has told you to turn down the volume and you've turned it down, and she comes back up to your room and she says, "Hey, I thought I told you to turn down that music." And you say, "I did." And she says, "I can't notice a difference because it didn't exceed her difference threshold." She couldn't tell you didn't turn it down enough in order to be able to tell that there was a difference. So, a difference threshold is the smallest amount of change that a person can detect 50% of the time. And we also call it the just noticeable difference. Now, sometimes our senses can adapt to certain environmental stimuli. So, for instance, let's say that you're sitting there in a chair right now watching this PowerPoint. Well, your brain doesn't need to keep knowing that you're sitting in a chair. So, you don't need to keep getting the message you're sitting in a chair, you're sitting in a chair, you're sitting in a chair. That's redundant. Your brain needs to be freed up so you can learn this information for psychology. So, sensory adaptation is when your senses adapt to the stimuli. They no longer need to get the information. So, it's like if you have you ever had that experience where you walk into somebody's house and you immediately smell, like maybe they have a cat or maybe they are a smoker, and you immediately smell that. But then after you've been there for a while, you don't really notice it anymore. It's not that the odor has gone away, it's just that your senses have adapted to it and they don't need to keep sending that information to your brain. It really helps to free your brain up for more important information. Now, there are certain extreme intense stimuli like a toothache or like the smell of chlorine or ammonia, or maybe even extreme heat that your senses don't necessarily adapt to. But certain stimuli, if it is unimportant or unchanging information, your senses adapt to that and don't continue sending the message to your brain. You're sitting in a chair, you're sitting in a chair, you're sitting in a chair. Nobody needs to hear that all day long. So this is kind of a fun activity that you can do to test your sensory adaptation. So hold your hand over one of your eyes or just close one of your eyes and stare at the dot that's in the middle of that circle on your right, that light colored circle. So you should have no difficulty maintaining and continuing to see the circle. However, if you do the image on the left and you close one eye and you stare at the dot in the middle, eventually it's going to be harder and harder to actually see that circle. So that gradual change that you have on the left-hand side doesn't provide enough contrast for your sensory receptors in your eyes to keep sending you the message of the circle. So the circle will only reappear if you close and then reopen your eye, or if you shift your gaze over to the X that's kind of there in the middle.